So, we're good. All right. Okay, we're going to do geometrics today. Geometric distribution. Woohoo! Another distribution, and you only get one down it. It's so easy.
To you, Barrett. Yes. To me.
Yes. It is so easy.
See, that's what I was gonna take. I was gonna do like accounting as a major. You know, I enjoy it because like you have to like really like take all the freaking math classes behind it, and I'm not good at math. So I was like, I'm just setting myself up for failure. So I was like, I'm not good at that.
Geometric distribution.
Good play.
Yep.
I had a whole pencil.
Okay, so binomial asks the question, after blank trials, how many times will I succeed? Right?
Yes.
Yes? Okay. Geometric is going to ask a different question. It's going to say, how many times do I need to try to succeed once and only once? You only get to succeed one time in geometric. It's like the difference in Ferris and Cameron.
What?
Have y'all seen Ferris Bueller's Day Off?
Yes.
Yeah? No?
Yes.
Well, if you have seen Ferris Bueller's Day Off, there's this monologue, and Ferris is talking about Cameron, and Cameron's kind of lame. It's kind of nerdy. He's like really high strung. And Ferris talks about how he's worried about Cameron because he's like, Cameron's never had a girlfriend, and he's kind of worried about Cameron because he's like the first girl that actually gives him attention. Like, he's gonna marrying her because like that's just how it's gonna work, and he's gonna be like treated like crap for the rest of his life because he's just gonna be dependent on all that positive attention. And he's like, Cameron never lives. He never like socializes and stuff. Nobody likes Cameron. And it's like when he like anyway. He talked about like parent issues and stuff. It's kind of a weird scene in this day when a kid's skipping school. Anyway, but it's the difference between Ferris and Cameron, because Ferris is like, I'm gonna live it up. I'm gonna go hang out with lots of people and get to know lots of people. And he's like, but Cameron, the first person who gives him positive attention, Cameron's gonna latch onto that person, and that's
That makes sense.
that's who he's gonna hang out with. So so if that helps you, cool. If it doesn't, then you can just be mad at me that you don't get that last 30 seconds of your life back. There you go. Good. Okay. Either way, we're good. Okay. So the formula. Do you want to do formula or conditions first? We should probably do conditions first, right? Conditions. All right. Conditions for geometric. You ready? It's awful. If you thought binomial was bad, just get ready. It's bits. It's binomial, independent, success probability, fixed, same. They're all the same as binomial, except the t. So we got our bins and we got our bits.
Okay. So what's the t?
Yeah, so what's the t?
What is?
Trials vary until first success. And that's our new one. Our conditions for geometric is that trials will vary until first success.
It's like when you're playing rock, paper, scissors with a little kid and they're gonna keep going until they win.
This would be like if you played rock, paper, scissors with a kid and they said, we're going to go until I win one time. Not until they get 3 out of 5, not until they get 4 out of 7, but until they win the first time. And then they rub it in your face that you had to play 9 games for them to win one time. Right? Because it's the first success.
And only once, right?
That you only get one success. We're not doing 2 successes, we're not doing 3 successes, we're not doing... you could actually do first failure, you just flip-flop your probability of success. If you want. I'm sorry? How many people do I have to ask until someone's going to want to take my survey? It's a good geometric question, right? Everybody's turning my survey down. I can't get anybody to say yes to taking my survey. How many people am I going to have to ask? That's a geometric question. There's no number of trials fixed. Okay. Formula is not on the formula chart, so you're going to have to memorize it.
Yay.
Fortunately, it makes sense. Probability that x equals k is going to be the probability of success times the probability of failure for all the other times. K minus 1. So like, what's the probability that you have success on the 5th time? Well, it's 1 success and 4 failures. So failure times failure times failure times failure times success. And that's the probability of getting success on the 5th time.
Can you work one? Do an example?
Yeah, we'll work an example in a minute.
Okay.
Okay. Like, what's the probability that, give me a probability.
Cars.
Of what? Cars? Sure, let's do cars. Let's say 30% of cars are red. So what's the probability of cars not red?
70.
70. So if I look at 4 cars, what's the probability that the 4th car is the first red car that I see? So it'll be 3 non-red cars and then a red car, right?
Mm-hmm.
So it's 70 times 70 times 70 times 30. That's the probability that the 4th car is the red car. Because there's 3 non-reds and then a red.
Okay.
Make sense? Right?
No. Yes.
That's good now? Okay. Things to note. In binomial, the lowest that it could be was 0. The lowest For geometric, the minimum is going to be k equals 1. And the maximum k is infinity. Theoretically, you could look at infinite cars because probability is based on the future. And so there is no guarantee. Even if 90% of cars are red, there is no guarantee that you will find a red car after looking at 3,000 cars. Probability is very low. You should check to see if you're cursed or something at that point in time. Or if you're wrong about the probability of finding a red car. If you've seen 3,000 non-red cars and you still think it's 90%, it's probably actually really likely that you're really wrong about that 90%. Or that you're colorblind. Yeah, that could also be the case. But it is possible, right? It is in the realm of possibility that you just see 3,000 non-red cars and that 90% of cars or 30% of cars are red. Does that make sense? Yes. And standard deviation, you don't have to know.
Good.
Cool. You do have to know the mean, though. Are you ready for the mean? It's not on your formula chart. Oh, no. But it's really difficult. Here we go. The average is 1 over p. Make sure I got that right. Yep, that's it. So, you know, if it's a 50-50 shot, it should take me about 2 tries. If it's a 10% shot, on average, it'll take me 10 tries before I get my first success. Sometimes more, sometimes less. If it's 20%, that's 1/5. So the expected amount of tries would be 5. Yes? This? The expected amount? The average expected value? This is average expected value of a geometric distribution. It's actually really easy. Would you like to work a problem? Would that be beneficial?
Expected value of distribution.
Yep. Okay, so let's make a problem. Give me a context.
Cards.
Cards. Okay, fine, cards. Okay, Jessica is doing card tricks.
I don't know what
Okay, so we'll call it Jessica's card tricks. Okay, so she's gonna have them draw a suit or draw a card and then match the suit. If she succeeds, she's gonna match the suit. So like she's gonna say pick a card, and if they pick a heart, she's gonna like go into their deck and she's gonna say, is this your suit? And if she succeeds, she looks good. And if she fails, she runs away in shame and tries again. because that's how you do magic tricks. You just keep trying, and you have the YouTube video out, and then you post the one video that looks good. And people be like, how you do that? And the real trick is, I just tried a lot of times. Eventually probability helped me out. Sound good? Okay, so first let's check our conditions. Actually, if we're doing the 4-step process of state, plan, do, conclude, we're going to state, if we're like, this is a fresh problem, it's on a test, the state part is you're going to say, hey, this is geometric. And you get 1/4 credit for telling me this is the geometric distribution. Like 1/4 of your points just come from identifying this is geometric. And if you identify that it's binomial, you lose 1/4 of the points, but then I have to follow your logic the rest of the way, and you can get full credit for all the other points, even though you did everything wrong, because it was a geometric problem. But you did it right under the assumption that it's a binomial.
Does that really have a grade?
That is how it's graded.
Just how you grade, or how?
That's how the AP test is graded.
Nice.
It's pretty nice, yeah.
I could be wrong.
If your work can be wrong on the do part, but your conclusion, if you base your conclusion based on your work, even if it's the wrong conclusion, if it's the right conclusion based on the wrong work, they still give you credit for the conclusion. It's a pretty cool game to play. So we say it's geometric distribution, so we're going to check our bits. You got to memorize it.
It's binomial independent.
So you can't just say B check, I check, T check, S check. You need to write out binomial success or failure. Independent draws. Trials vary until first success. Whoops. Success probability is fixed. If you're on a test, you're writing all of this out, or you're not getting full credit.
Was that one thing, trials?
Trials vary until first success, which oddly enough is the same thing I wrote right there. So if you can learn to memorize some notes, you can learn to get some credit, which is really nice on a math test, because usually that's not how that works. But this is half the points right here.
You have a good half credit.
It's a good half credit. Yep. So far so good? Okay, and we're going to write our formula down. Probability x equals k equals p 1 minus p k minus 1. So now we can ask questions like find probability she has to try trick on let's say 3 people. Okay? So we're going to find the probability. She has to try the trick on 3 people. So it's probability x equals 3. Alright, up here we're going to write a probability real quick. If there's 13 hearts, right? Someone pulled out one of the hearts. So how many hearts are left?
12.
There's 12 hearts left. Out of how many total cards?
52.
51.
Oh, 51.
Because they took one of the cards away. There's 13 hearts total. And when we're doing the magic trick, they have one of the cards. So they're holding the heart.
So you have 51 cards.
So now there's 12 hearts in the deck out of 51. So this magic trick will work 12 out of 51 times. If not, she takes her card, runs away, and tries it on someone new. So it's a little less than a fourth. I think it's less than a fourth. Yeah, it's less than a fourth. Alright, so here we go. Probability is going to be 12 out of 51 times 1 minus 12 out of 51, 3 minus 1 equals. For those of you who think you have to type that in your calculator, you are wrong. There is good news today, because this continues to be the great show that we know math. Because we're going to do all of this in our calculator.
Wait, what do we do?
It's wonderful.
Menu 6.5. What do we do? Other geometric PDF. Hey!
Menu, statistics, distribution. And remember, if you don't memorize the settings, if you actually learn to read the menu, this is actually really easy to navigate, because this is geometric. I want to find a single value, so this will be a PDF, right? It only asked me for 2 things, which is good because I only know 2 things. I know my probability of success is 12 over 51, and I know my x value is 3. There we go.
0.13.
3, because I gotta try 3 times. 0.138.
PDF is only once, right? And it's
PDF is 1 time, CDF is multiple times. Alright. Let's try another one. What about find the probability? She tries on 3 to 7 people. So let's find the probability. She tries on 3 to 7 people. So the probability that x goes from 3 to 7. I've already written my formula. I've already carried my formula out once. So I do px equals 3 plus dot dot dot. Px equals 7 equals, I can just write my answer down. You only have to write the formula once. You only have to write the formula carried out once. And after that, you can just do your CDFs all you want. It is wonderful. Menu 6.5, geometric CDF.
And that's going to be 12 over 51.
12 over 51, right? Lower bound is 3, upper bound is 7. 0.432.
I wonder if that actually works. It's a diamond.
We good? One more real quick so you guys don't get confused. We're not confused yet, right?
No. That's easy.
This is an easy little section.
Yeah.
Kind of looking forward to this quiz. But like, bring it. Let's go. I hope so.
Is it tomorrow?
No. Tomorrow might be practice AP test, I think. Okay, probability. More than, let's say more than 6 people. Probability she talks to more than 6 people. This is the probability x is greater than 6. So it's probability x equals 7. Don't do 6 on this, because 6 is not bigger than 6. 6 is equal to 6. The first number that is bigger than 6 is 7. Right?
Yep.
Yep. Yeah, some of you would have put 6 on that. Sad day.
Oh,
Plus probability x is 8 plus dot dot dot. You can just put the dot 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 because it goes to infinity. It's fine.
put that in the calculator?
I
Mm-hmm.
thought you had to put at least 3 values. To put the dot, dot, dot.
That's fine. It's probably a good practice to put 3 values, but
Who would you? So
I'm running out of space.
You're doing CDF?
Menu 6.5. Yep, CDF. 12 over 51. We're going to go 7. What's my other round? I can't type infinity. Sure, let's do like 399. 3 nines.
Dot, dot, dot.
No, you can't put dot dot dot. Just put like 1,000 tries. There you go. Because I could try it again. And I could put like a whole another 9. Look at that. Like I can keep adding 9s to this.
And it's still gonna be different.
It's the same number.
Okay.
Because it's about 20% that it's going to happen after the 7th trial. After the 6th trial. Make sense? We're good?
That's it?
That's all I got for today. That was so easy, right? You got 15 minutes. You can like look at homework or something. That's a weird feeling.
That's
All right.
very
Awkwardly silent.